Most Claude tutorials show you the chat window. If you're automating anything real in your business, 97% of Claude's power lives in 3 API features almost nobody teaches. You're stuck watching demos of poetry and recipes while your automation bill silently doubles. I'll show you all 3 running in production, with real cost graphs, real accuracy numbers, and the exact code blocks. Most creators skip this because they've never shipped Claude past a demo. By the end, you'll know what to wire in, what to skip, and the one combo that quietly burned my budget for a week. I'm Lazar. I ship these systems for clients every week. Let's open the first one. Here's the scenario you probably recognize. You tried Claude in the chat. It felt smart, so you wired it into your business. Maybe it reads incoming emails, classifies invoices, drafts replies, pulls data out of PDFs. 2 weeks in, 2 things happen. Your monthly bill is 3 times what you expected, and roughly 1 in 10 outputs is just wrong enough to embarrass you in front of a client. So you start patching. You add retries. You add validators. You add a second model to check the first model. None of that fixes the root cause. The root cause is that you're using Claude like a chat tool when you should be using it like an API with 3 very specific features that change the economics and the accuracy completely. Almost every tutorial out there teaches the chat surface, artifacts, projects, the web app. That's fine for knowledge workers. But if you're automating a workflow, that knowledge is not what scales. What scales is prompt caching, extended thinking, and structured outputs through tool use. Those 3, used correctly, are the difference between a Claude integration that costs you $4 a day and one that costs 90 cents, between 91% accuracy and 98%, between a brittle JSON parser that crashes on weird quotes and a schema that survives 12,000 calls without a single malformed response. Let's go through them one at a time, the way I actually wire them for clients. Feature 1 is prompt caching. Here's the problem it solves. Every time you call Claude, you're paying input tokens for everything you send. System prompt, instructions, examples, context documents. If you're running an email classifier that processes 200 emails a day, and your system prompt is 3,000 tokens of instructions and few-shot examples, you're paying for those 3,000 tokens 200 times a day. That's 600,000 input tokens just for the static part that never changes. Prompt caching lets you mark a block of your prompt as cacheable. Claude stores it on their side for 5 minutes, and every subsequent call within that window pays roughly 1/10 the price for that block. In the API call, you add a cache control field with type ephemeral on the content block you want cached. Put it on your system prompt. Put it on your long context documents. Put it on your tool definitions. The order matters. Cacheable content goes first. Dynamic content goes last. Because the cache works on a prefix match. If anything before the cache point changes, the cache misses. On one client system processing inbound business email and routing it to the right Telegram channels, the daily Claude bill dropped from about $4.20 to about 90 cents on identical workload. Same model, same accuracy, same volume. 78% reduction, just from adding 3 lines to the request. When does it break? When your traffic is too sparse. If your calls are more than 5 minutes apart, the cache expires and you pay full price plus a small write penalty. So caching is a win for steady workloads, a loss for once-an-hour cron jobs. Measure before you assume. Feature 2 is extended thinking. This one changes accuracy on hard tasks. Extended thinking lets the model reason internally before producing its final answer. You enable it by passing a thinking parameter with a budget knocks toe to tokens value. The model spends those tokens reasoning to itself, then writes the actual response. You pay for the thinking tokens, But on the right tasks, it's the cheapest accuracy upgrade you can buy. Where it matters. Invoice classification is a good example. You have a PDF, you've extracted the text, and you need to decide, is this a purchase invoice, a sales invoice, a credit note, a delivery note, or a quote? Subtle differences. Same vendor can send all 5. On a 500 invoice test set with no extended thinking, accuracy sat at 91%. Turning on extended thinking with a budget of 2,000 tokens pushed it to 98.4. That's the difference between a system you trust to run unattended and one that needs a human reviewer. When not to use it, simple extraction tasks. If you're pulling a date and a total from a clean invoice, extended thinking just burns tokens for no gain. Reserve it for classification, multi-step reasoning, or anything where the model has to weigh ambiguous signals. Feature 3 is structured outputs via tool use. This is the one that ends the entire category of bugs called the JSON broke again. You've probably tried asking Claude to respond in JSON, maybe with a schema in the prompt, maybe wrapped in markdown code fences. Sometimes it works. Sometimes it adds a friendly sentence before the JSON. Sometimes the string contains an unescaped quote. Sometimes it just hallucinates an extra field. The fix is to stop asking for JSON in the prompt and instead define a tool. You give Claude a tool with an input schema, and you force it to just a tool just ace too. The model is now constrained at the API level to produce arguments that match your schema. No prose, no markdown, no surprises. The arguments come back as a passed object, not a string you need to regex. On a production system handling around 12,000 calls a month, that pattern hasn't had a single malformed response. 0 retry logic. 0 JSON repair. The schema enforces the shape, the model fills in the values. Now the part nobody covers, stacking all 3 in one request. You can cache your tool definitions and system prompt, enable extended thinking, and force a tool call, all in one API call. The order in the request body matters. System prompt with cacheway control first, then tools with cacheway control on the last tool, then the thinking parameter, then the user message, then tool unstashway controls forcing your output tool. Get that order right and you get cheap, accurate structured outputs in a single call. Here's the failure mode I hit so you don't. There's one combination that quietly doubled my bill for a week. If you enable extended thinking but also stream the response and don't cache the thinking eligible prefix correctly, the cache silently misses on every call. The bill goes up, the latency goes up, and nothing logs an error. The fix is to verify cache hits in the response metadata, every call and alarm if the hit rate drops below your baseline. I run a small cost monitor on a home server that pulls the usage field from every response and graphs cache red underscore pit stock T2 kens against cache re-h thux correlation underscore T2 kens. If the red ratio falls, I get a telegram ping. That single dashboard has saved more money than any prompt optimization I've ever done. So that's the 3. Prompt caching for cost. Extended thinking for accuracy on hard reasoning. Structured outputs via tool use for reliability. Stack them in the right order. Monitor cache hits, and your Claude integration stops being a demo and starts being infrastructure. If you want the exact AP, I call templates with cache control, thinking budget, and tool schemas already wired, plus the cost monitor that catches silent cache misses. See what we ship for clients at BizflowAI.io. Hit subscribe and ring the bell so the next production breakdown lands in your feed. And if you've got a workflow you want automated end-to-end, book a free 30-minute discovery call at BizflowAI.io and we'll map it out together.